Okay, so we're faced with a bearings question here, but because the question quite clearly states that the diagram is not drawn to scale, that means that we can't use protractors to measure these angles. Instead, we have to use our knowledge of angle properties of parallel lines and the fact that the north-south line, wherever we draw it, would be parallel to any other north-south line in order to solve this particular question. So the first thing that we need to work out is the bearing of the yacht from the lighthouse. Now the emphasis here is from the lighthouse. That means that we are actually standing at the lighthouse and we need to find the angle that we turn to move from north until our line of sight is facing the yacht. So this is the angle that we need to calculate. North-south is a straight line, so the angle property that we need to use here is the fact that angles on a straight line add up to 180 degrees. So these two angles must add up to 180. So the bearing of the yacht from the lighthouse is going to be 180 degrees less the 60 degrees that is marked. So that's going to give us an angle of 120 degrees. Part B, we want to find the bearing of the ship from the lighthouse. So again, we're standing at the lighthouse and we need to find the angle that we turn through to go from north all the way around until our line of sight is looking at the ship. So this is the angle that we need here. Well, we know that from north to south is 180 degrees. So if we can find this angle here, then we can add that to 180 degrees and that will give us the bearing that we're looking for. As I said, north-south are parallel, so this north-south line here and this north-south line here are parallel. Perhaps if I turn the page that way around, you'll be able to see a little bit more clearly that we have an alternate angle there, the Z angle as we know it. So that angle there is 52 degrees, where it forms the Z with this here, that is also 52 degrees. So I know that that part is 52 degrees. So the bearing will be the 180 from north to south plus the 52 degrees there, giving us an answer of 232 degrees. And that's that question. In the next question we have three pairs of parallel lines. This has got nothing to do with bearings, but again the diagram is not drawn to scale, so we aren't able to measure anything. Now again, what we have here are corresponding angles. That means the same angle on one parallel line will be identical to the size on the other. So if that's 70 degrees here, that is parallel to that. That means that that angle there must also be 70 degrees, as must this angle here, because it's also part of a parallel line set. So X, we worked out straight away, is 70 degrees because of those corresponding angles. Now, in order to get into find angle Y, it's inside a triangle, so I know that the angles inside a triangle add up to 180 degrees. So if I can work out that angle there, then I'll know two of the angles and I can calculate the third. Because I've spotted that we've got these three sets of parallel lines and each of those angles is 70 degrees, what I have here is a straight line. Angles on a straight line add up to 180, so I can just take the 70 off 180 to give me that internal angle there is 110 degrees. That means I know two out of the three angles in my triangle, so in order to find Y, I need to take those away from 180. Well, 110 and 30 is 140, so I have to do 180 degrees, take away the two angles that I know, come to 140, so Y is going to be 40 degrees. Okay, and the final parallel line question. Again, has 3 parallel lines. So I know that if that is 55, that one there is 55, and that in there is also 55 degrees. So x straight away we can write down as 55 degrees. Now that I've identified that that angle there is 55 degrees, I have a straight line there, which means I know that y and that 55 must add up to 180. So y is going to be 180 less 55, which is going to be 125 degrees. And then finally, I'm inside a triangle. I know what those two sides are. So the third side is going to be 180 minus the sum of those two. So 85 and 80 and 55 will be 135 degrees. So I know that those two come to 135. So Z will be the 180 degrees that the 3 of them have to add up to, less the 135 degrees, which will be 145 degrees. And then part B has got nothing to do with parallel lines. It's to do with a regular pentagon. Exterior angles. The exterior angles of any polygon add up to 360 degrees. You need to know that a pentagon has 5 sides. So what you actually have to do here is 360 divided by 5. This will be on a non-calculator paper, so you need to be able to do that division without a calculator. 5 doesn't go into 3, it goes into 36. 7 5s are 35 times, remainder 1. 5 goes into 10, 72. So the exterior angles will be 72 degrees.